Hi, good morning. This video is to help you complete today's lesson, and I won't be here, so please look through this and you should be able to complete today's lesson, which is on calculating dilutions. Now, there are two activities here, calculating dilutions as well as concentrations of solutions. Now, this is a PhET simulation. However, the main lesson I'm going to go over is this first one, calculating dilutions. I'm going to click on it. Now it's going to take you to the screen for the activity, how to calculate dilutions of solutions. So click read. Now today's lesson objective, at the end of this lesson, it is expected that you will be able to use the dilution formula to calculate the dilution of solution or the concentration of solutions. Now the essential question is, how would you use the dilution formula to find the concentration of a solution? Now a little bit of the background information. Why is dilution very important? Chemists, doctors, biologists, they depend a lot on dilutions. Like in the hospital, in the emergency room, when a doctor prescribes an IV for a patient, the aide or the nurse that is going to apply or give the IV must make sure that he or she use the correct concentration. And most times, this IV comes in a very high or large concentration. So which means that as a nurse or as an aide working in a hospital, you have to know how to dilute the IV to the prescribed concentration. And most times, water is used in diluting the concentrated IV. Because if you give a very high dose of concentration, that could lead to the death of the patient. Okay, now if you click on the next screen, here we'll have a very short video that kind of go over the dilution equation, how to use it. So I'm going to play it, and then I'm going to see the examples as given by the speaker. Okay, well, let's watch this. 3 minutes.
In this video, we are going to look at what dilutions are in chemistry, how to calculate them using a very easy equation, and even extending to multiple dilutions, which are called serial dilutions. I am sure you all already know that when you have orange squash and you dilute it, that just means you add water. It is the same in chemistry. Dilution is the process of adding water or another solvent to a solution to decrease the concentration. Exactly the same as your orange squash. You have it strong, or you can add more water and make it weaker. So you just need to remember that to dilute a solution means to add more solvent to a set amount of solute, therefore increasing the total amount of solution and decreasing the concentration. So, why do we dilute things in chemistry? In laboratories, solutions usually come in small concentrated volumes so that they are easy to store. You then need to dilute them to a known lesser concentration to use them, such as for titrations. But dilutions are really important for many other things too, such as for doctors and in microbiology. The good news is that there is a very easy equation to help us calculate dilutions. M1 V1 equals M2 V2. Let's have a look at where it comes from, and then we'll see what it means. Because the moles of the solute stays the same before and after diluting, we can say that moles of solute before dilution equals moles of solute after dilution. And then you should already know that moles of solute equals concentration times volume. We can substitute this in, and we get the concentration multiplied by volume before is equal to the concentration multiplied by volume after. which is what this equation is telling us. I'm just going to pause this video for 5 seconds, long enough for you to save that equation to memory. M1 V1 equals M2 V2. Could it be any simpler? Let's now have a look at how to use this easy peasy equation. So we have our M1 V1 equals M2 V2 equation. Here, our before values are M1 equals 1, and we don't know V1. Our post-dilution values are M2 equals 0.6 and V2 equals 150 moles. Substituting in these values, we get 1 times V1 equals 0.6 times 150. So V1 equals 90 milliliters. That wasn't too tricky, was it? I told you it was a nice and easy equation. Watch the second part of this video to see how to use this equation for serial dilutions. Serial dilutions are just multiple dilutions and are no harder than the example we have just seen.
Okay, so that's a very short video. Now let's see if we can complete this activity at the bottom. It says drag the words into the correct boxes. To dilute a solution, you add water to decrease the concentration of the original solution. Now, chemists, biologists, and doctors use dilute solutions in the course of their work. When diluted, the number of moles of solute remain the same. All right, so you check and see if you're correct, and then you move on to the next screen. Now, in this case, we're going to look at dilution similar to what it did in the video. You see these two pictures, A and B, two beakers, and you can see both of them contain the same number of solute, but both of them contain different amount of solvent. So in beaker B, you have more solvent than in beaker A, but both of them contain the same solute particle. Now, when you dilute a concentrated solution, which is shown in beaker A, by adding solvent, the concentration of the solution is lowered. What it means is that you have more solvent compared to the number of solute, but the total number of moles of solute present remains the same. It doesn't change. The only thing that changes is the amount of solvent. Remember, solute is what dissolves in the solvent to give you a solution. Solvent, in most cases, during dilution, is going to be water. All right, now calculated dilutions. You can use the molarity to calculate the dilutions of solutions. Now, to calculate dilution, you're using the formula M1 V1 equals to M2 V2, where M1 stands for molarity of initial solution and V1 stands for volume of initial solution. M2 is the molarity of the final solution, and then V2 is the volume of the final solution. Now, unlike the formulas for calculating molarity, the formula for calculating dilution, we can use liters or milliliters. It doesn't have to be in liters. However, both of them, both the V1 and the V2, must have the same unit. So which means that if you have V1 in liters, V2 must be in liters. If you have V1 in milliliters, V2 must be in milliliters. Now, what happens if one of them is in liters and the second one is in milliliter? The only way you can do that is to convert one of them to the other. That means if the first one, the V1 is in liters and the second one is in milliliter, and you want to use milliliter, you have to change the V1 to milliliter by multiplying the V2 or whatever value you have in liters by 1000. But if the V1 is in liters and the V2 is in milliliter, and you want to use liters, that means you have to convert the V2 to liters by dividing by 1000. Okay, so that is the main difference between the dilution equation and the molarity equation. Now, answer the following question. Which of the following statement is / are correct? So here you can have more than one correct answer. Less concentrated solution cannot be made from a more concentrated solution. That is false. Dilution can be calculated by using M1 V1 equals to M2 V2 formula. That is correct. Less concentrated solution can be made by adding solvent, which is usually water, to more concentrated solution. That is true. When a concentrated solution is diluted by adding water, the total number of moles of solid in the dilute solution remains the same. That is correct. Okay, so in this case, we have our 3 correct answer choices. Now, once you're done with that, you click on next. That gives you the dilution formula itself. You have to walk through this to see how to use the dilution equation. We already know that M1 V1 times V1 is equal to M2 times V2. You check, which means it's correct. Now, how do we rearrange this formula to solve for an unknown variable? In this case, the unknown is M1. If the unknown is M1, we have to rearrange this to solve for M1. So M1 is the unknown, so it goes here. It's always with question mark. And then the one that goes at the bottom, the easy way to remember this is that the one that goes here, the unknown, will also be the same right here. That means both of these one have to be 1. If this is 1 here, this has to be V1. So which means that the V1 goes at the bottom. So whatever goes with this one here is the one that goes as a denominator. And then the other ones cannot go up. Sure, this can be in any way. It doesn't matter. I can put it right here. I can put it here. It doesn't matter. So you check and see that it's correct. So M1 is equals to V2 times M2 over V1. Remember, this, whatever goes at the bottom, is the one that goes with the unknown. Now here, let's solve for V1. In this case, V1 is the unknown, so which means that V1 goes here. And guess what? M1 will go at the bottom because they have to go together. And then M2 and then V2. Remember, it doesn't have to be M2 first. It can be V2 first and then M2. So check and see that is correct. So to solve for V1, you multiply M2 times V2 divided by M1. Now for activity 4, we're solving for V2. V2 is the unknown, so it goes here. So which means that your M2 will go at the bottom. So M2 will come here, and then the V1 and the M1 will go on top. So that will give you your V2. Whereas to calculate M2 here is the unknown. So M2 goes here, and of course your V2 comes down here. And then M1 times V1 will go on top. So that's how you calculate your M2. Now, this kind of gives you practice on how to rearrange the equation for calculating dilution in solving for an unknown variable. Okay, so once you click on the next one, here, that's where we're going to practice using those equations in solving for the unknown variable. So here we ask, it says for Alex needs to complete a lab experiment. He needs to make 150 liters of 0.25 molar sodium chloride solution. What molarity would sodium chloride need to be if he has 0.7 liter of the solution? So that is what it has, 0.7 liters. So 0.7 liters is the initial volume. So it comes there, 0.7. So which means that what molarity would, that means it's the M1 we're looking for. So you put a question mark right there. And then it says for Alex to, you need to make 150. So 150 liter is the final volume. So that's 1.5 liters. And then the 0.25 molar M is the final molarity. So it's going to be 0.25. So you always have to read the question in order to determine which one is the initial and which is the final. Always know that the initial is what you're starting with and the final is what you need to have. Okay, so I'll check this, see our extraction is correct. And then you now plug this one in here based on the formulas for M1. We know here, based on this equation, we know that M1 is equals to M2 times V2 divided by V1. So if I go here, which means that my M1 is the one that comes here, and then my V1 is the one that goes at the bottom. So my V1 here is 0.7. So I put 0.7 down here. So I automatically know that the other two goes on top. It doesn't matter which one goes into which on top. So this will give me my M1. So you're going to use your calculator to multiply. You're going to multiply 0.25 times 1.5. So let me see if I have a calculator here. Okay, good, as a calculator. So I'm going to multiply 0.25 times 1.5. 0 divided by 0.7 equals, so that gives me 0.53 with a bunch of number. But here we're asked to round our answers to 2 decimal places. So which means that I'm going to round this one up to 2 decimal. I'm going to stop here, but this is 5. So I'm going to round this one up to 1 and add it up to this 3. So which means that my answer will become 0.54. So that's what I'm going to type in here, 0.54. I check, see that we're correct. Okay? That's the first practice problem. So the second one is the same thing, but in this case, we're asked to find final volume, V2. So you're going to put the question mark right here. And then we're going to read the question. George wants to prepare 1.5 molar solution of sodium hydroxide. He wants to prepare 1.5. So which means that that is the final molarity, 1.5 M. So I'm going to put right there 1.5, which is the final molarity he wants to prepare. Now it says how many milliliters of water should he add? We already know that that's your V2 because that's your final volume that you want. So should he add to 250 milliliters of a 5 molar stock solution? So in this case, this is going to be my V1, and then this is going to be my M1. So my V1 is going to be here. Sorry, my M1 is going to be here 5, and my V1 is still going to be 250 right there. So I'll check. That means it's correct. So we asked to find V2, so which means that V2 goes here. And we know that whatever goes at the bottom must be the same, must go with the unknown. So in this case, what goes with the unknown is M2. So M2, based on what we have here, M2 is 1.5. So which means that 1.5 will be at the bottom. So this could be, this 2 now goes on top. So we check, see that we're correct. Okay, so you're going to use your calculator. You're going to use your calculator to multiply those on the top. 5 times 250 divided by 1.5. So that'll give you 833.33. So it's going to be 833.33 because it asks you to do it round your answer to 2 decimal places. So that will mean it's correct. Okay, so we've done 2 together out of 4. So if you go on to the next screen, Use the same thing. I want you to do these two on your own based on those ones we've done. They are the same. Here you ask, the number 3 is asking you to find for M2. So M2 is the unknown. And then number 4 is asking you to find for V1. So which means that V1 is the unknown. So extract the information from the question, put them here first in the boxes before you solve for it. So read the question. It says, what is the molarity of 2.1 liter of solution of iron 2 phosphate produced from? So it's telling you already this is the initial volume and this is the initial molarity. Initial volume V1 and this is your V2 3.5. So which means that 2.1 is your V2, which is your 2.1 liters. So your M2 is the unknown. In number 4, you give it says a 135.4 milliliter solution of Kb potassium bromide with 0.5 molarity had an initial concentration. So here they already told you that this is M1, initial concentration, M1. And then it says, what was your original volume? So which means that you're asked to find V1. V1 is going to be your original volume. So you have your V2, which is 135.4, and then you have your M2, which is 0.5. You plug them in here, and then drag and drop the values into the equation to solve for V1. And then you multiply those two, divide by the one at the bottom to give you your initial volume. So make sure you round this to 1 decimal place like this one says. Okay, and then you check, and that's it. Once you're done with that, you click submit report, and then you'll be good. All right, so please try and finish this. If you have any other thing to do that you've not done, please complete them, because this Friday is the end of the third 6 weeks, and then your progress report will be ready by next week. So make sure everything that you're missing, you try and do them, and then turn in your work. And that's it. I hope to see you, those of you that face to face, I hope to see you on Friday. On Friday, we're going to take a test on solutions. We're going to do some quick review, Kahoot review, and then we will take the test. Okay? You take care.